The old joke about Werner Heisenberg being pulled over and the cop says, "You know how fast you were going?" And Heisenberg says, "No, but I know exactly where I am."
Okay.
Because you can't know, according to the Heisenberg uncertainty principle, both your velocity and position at the same
That joke
time.
rocks at physics conferences.
I was going to say, who wrote that? Can I try that out? I don't know.
That's the uncertainty principle. No one will pin you down. In quantum mechanics, you're fundamentally not a set of particles. You're a set of waves.
Right.
If the Planck constant, which sort of sets the scale for quantum physics, were much bigger, macroscopic, then we would all be these kind of undulating waves moving through the universe, interfering with each other and becoming entangled and then measuring things. And we don't want to live there. It's not no place to be, really.
And so you mentioned entangled. That's been a buzz phrase.
Everybody loves it.
Everybody loves it.
It's one of the biggest hits.
Hearing about
it's one of the biggest hits right now. Entanglement.
Entanglement. So one of the goals is, what's the farthest particle that you can entangle, on the premise that maybe that'll be useful one day.
Right.
And from all the news articles I've seen, China leads the world in entangled particle distances. So what do you have to do?
Well, no, I'm sorry, because I'm just losing something right here. I'm missing something. If something is entangled, what difference would it make about the distance? I'm missing that.
Who knows? I'm saying in science, you just push the envelope if you've never pushed it before.
I got you.
One day, we heard in Congress, did you hear in Congress? China is going to land something on the far side of the moon, and Congress wants to know why. How come we're not landing something on the far side of the moon? This was an entire conversation in Congress.
Right, right.
No, but Chuck is completely right about entanglement. It doesn't matter how far away things are, but the problem with two entangled particles, which we haven't even defined what that means, but you have a very sophisticated audience, so they know what this means, is that as soon as you measure one of them, the entanglement breaks. So it's not that they get further apart, it's just that as you bring them further apart, the chances that one of them bumps into something gets bigger and bigger.
And so therefore, so that's what makes this distance record meaningful as a record. So one of them was they entangled particles between orbit and Earth's surface. And another one was they entangled particles inside a fiber optic network, 50 kilometers, which is about city size. And so then the suspicion is, with entangled particles, you might be able to make a secure internet, undecodable,
unhackable.
Unhackable.
You can't decrypt it. Encryption wouldn't make a difference at that point.
Right, because it's instant. So